Alright guys, we're still looking at lesson 4.4, factoring polynomials. And here's the formulas that you definitely need to have in your notes, and these need to be committed to memory as well. So you're going to see here, these formulas, the difference of two squares, a squared minus b squared equals a plus b times a minus b. Now, when you think about this, you need to know what a difference of squares is, the formula, but you need to know, actually understand what it means. So it's got a number squared minus another number squared, and that equals the same binomial with a different sign in the middle. Okay, so these are similar to conjugates, but anyways, when you think about this, don't just think about the a's and b's. Think about what you actually have. A number squared minus another number squared, and that equals the same binomial, different sign in the middle. All right, same thing down here. When you have a binomial squared, this is in factored form. If you have a binomial squared, that means you've got a plus b times a plus b, because something squared means this times itself. All right, so you can go to this factored form very quickly if you have two squared terms on the front and back end, and you have twice ab in the middle. So if you have, for instance, x squared here and 4 here, you know that a is 2, x and b is 2. So this would be 4x in the middle. And that would be factored very quickly as x plus 2 quantity squared. So don't just memorize the letters. If they don't mean anything to you, it's not helpful. And then the sum or difference of cubes, these are new this year. You can see the sum of cubes starts with a plus, difference of cubes starts with a minus. These are basically the same formula, but they have different signs on the front two parts. This can be easily memorized using SOAP. If you can remember same, opposite, always positive. All right, so you got a number cubed minus another number cubed, so that's a difference of perfect cubes. So that's going to be a minus b, same sign, and then a squared plus, this is the opposite sign, so if this is minus, this is plus ab, and then always positive. A number squared is always going to be positive. So if you remember SOAP, that tells you what your signs are for a sum and difference of cubes. Same thing down here. We have a perfect cube plus a perfect cube. And then that can be factored into a plus, same sign, a plus b, times a squared minus, opposite sign, a plus here and negative here. And then again, always positive. Anything squared is always positive. All right, also perfect squares, perfect cubes, you should commit these to memory. If somebody says 49, you should automatically think 7 times 7. Same with 216, that's 6 cubed. So this perfect squares and perfect cubes comes with good multiplication skills, good number sense, and the better number sense you have, the easier factoring is going to be. So if you're really good at multiplying and you're really good at seeing how numbers relate and connect through multiplication and division, factoring is going to be a whole lot easier. And that's something that you can practice at any point in time. So if you're not good at it, just take a few minutes each day and work on that so that you get better at it. All right, let's look at a few just examples of factoring. All right, it says factor the polynomial over the integers or identify it as irreducible. Okay, integers just means we're working with positive and negative whole numbers. We're not going to be working with fractions. So if we look at this first one, we can tell that 15 goes into both numbers and x goes into both of the variables. 15x times 3x squared, or 15x times 3x squared is 45x cubed, and then plus 1. You always have to have a placeholder here. You can't just leave that as 15x times 3x squared, because that just gives you 45x cubed, and then you're forgetting about the second part. Remember, factoring is just rewriting this expression in factored form. Still has to be equivalent. All right, the next one, 3, 6, 24, they all have a common factor of 3, and then they all have a common factor of x. So pull out my 3x, then I'm left with x squared plus 3 goes into 6 twice, I pulled out one x, so I have one left over. 3 goes into 24 negative 8 times. X was already pulled out, so I don't have an x left on the end. All right, my 3x comes down. I'm going to see if this factors further. So I'm going to have my two binomials. We did a lot of factoring with quadratics last year in Math 2. So x times x is x squared. What multiplies to give me 8? 1 and 8, and 4 and 2. I needed 2 in the middle, so I'm going to do 4 and 2. I need a positive 2, which means my bigger number gets the positive, smaller number gets the negative. Then you can quickly check it and make sure that it equals. X times x is x squared. X times 4, 4x, minus 2x is 2x in the middle. Negative 2 times 4 is negative 8. So again, this is factored form for this polynomial. All right, this is a perfect cube. It's from that list of perfect cubes. 1 is a perfect cube. 1 times 1 times 1. All right, so this is a difference of perfect cubes. So I need to know A is 5. And my B is 1. And then I know that the first one is same sign. So I'm going to have 5x. That should have an x with it because that's an x cubed as well. And then I'm going to have a minus 1. That's my A minus B. And then I'm going to have A squared. So I'm going to square the 5 and the x. And then I'm going to have the opposite sign, same opposite. Opposite sign is positive. 5x times 1 is 5x, and then always positive on the end. B squared, 1 squared is just 1. All right, so this could be factored as 5x minus 1. It's going to be 25x squared plus 5x plus 1. All right, let's bring the last one down here on the bottom so I have a little bit more room. So I've got negative 2 comes in all of those. So I also have an x squared that comes out of all of those. And I'm going to have x squared, because x squared times x squared is x to the 4th. And then negative 2 goes into 12 negative 6 times with one x left over. Negative 2 goes into negative 10 5 times. And x squared's already come out, so it's just a 5. All right, now what we need to do again is see if this will factor further. So I'm going to have negative 2x squared. I've got x times x. What multiplies to give me 5? 5 and 1 are the only things that multiply to give me 5. Now I need to add to get a negative 6 in the middle, which means 2 negatives multiply to give me a positive. 2 negatives, negative 1 and negative 5, add to give me negative 6. If you multiply all of this together, you should get what you started with, which means this is the factored form of that polynomial. If you need to pause this and take notes, please do so. We're going to move right on through these. All right, factor by grouping. All right, the first one I'm going to factor out an x squared. And I'm left with x minus 7. And then I'm going to factor out a negative 1. And I'm left with x minus 7. Because negative 1 and negative 7 give me plus 7. Remember, now we can factor out the common factor, which is x minus 7. And we have x squared minus 1 is our other factor. If you recognize this, perfect square, difference of squares. So I've got x minus 7. So x plus 1, x minus 1. Same binomial, different sign in the middle. Okay? All right, here, factor by grouping. So I'm going to pull out a 2x squared. And I'm left with 5x minus 4. And then with this one, I'm going to pull out a 5. And I'm left with, yeah, that's right. So 5 5s is 25x. 5 4s is 20, so minus 4. All right, bring out my greatest common factor, which is my binomial now. 5x minus 4. And then 2x squared plus 5. 2x squared plus 5 is my other binomial. All right, at this point, this will not factor further, nor will this. So this is factored form. If you multiply it, you can see that it is what we started with. All right, one more, factor by grouping. All right, if I pull out a 2x to the 6th out of the first term, I'm left with an x cubed. And 2x to the 6th, I need a placeholder, so I'm going to put a 1 here. Then I'm going to factor out a -1, and I'm left with x cubed minus 1. So I have 2x to the 6th minus 1, and I have x cubed minus 1. Again, this doesn't factor, but this is a perfect cube, this is a perfect cube, so you recognize that this is a difference of perfect cubes. So you're not done factoring until you factor it completely. So I'm going to have x minus 1, and then x squared plus ab, which is x, and then plus 1 on the end. And that's supposed to be a parentheses. I don't know what happened there. All right, again, if you need to pause this to take notes, please do so. All right, now it says find the real solutions. Okay, so we're going to first factor. So here we've got x squared times x minus 4. So we're going to have x squared equals 0. Again, this is the zero product property. We did this last year, but we're going to do it again. X equals, take the square root of both sides. X equals plus or minus 0. There's really not a plus or minus 0. So it's really just 0. Most of the time when you take a square root, you do plus minus. Here you're going to add 4 to both sides. X equals 4. So this has two solutions, 0 and 4. All right, the next one, I'm going to factor out just an x. So I'm left with 3x squared plus 4 minus 5 equals 0. So I got x equals 0 as one solution. Then I multiply the top, front, and the last to factor this one. It's going to be negative 15. 1 and 15, 3, and 5, neither of which give me a 4. So this will not actually factor. So we're going to have to use the quadratic formula for this. So we're going to do negative b, which is negative 4, plus or minus the square root of b squared, which is 16, minus 4 times a times c, all over 2a. All right, so I've got negative 4 plus or minus. So this is going to be 16, 4, and 5 is 20. 20 times 3 is 60, so that's plus 60. And then over 6. So I'm going to have negative 4 plus or minus the square root of 76 over 6. All right, let's bring this up here. So we've got negative 4 plus or minus 76 is 4 times 4 goes into 7 once, 16, so 4 goes into 16. Sorry, I'm trying to multiply in my head. 19. 4 times 19 is 76. Divided by 6, and that equals negative 4 plus or minus. The square root of 4 comes out as 2. Square root of 19 over 6. And these reduce. All three of these have a common term. So they all reduce by 2. So it's going to be negative 2 plus or minus square root of 19 over 6. So you've got one solution of 2 or 0, and then two solutions there that are not perfect squares. But our video, we're running out of time, so I'll finish the others on the next video.